Hi, welcome back. Remember before the break, we looked at the pie and we said that a pie graph showed a circle which represented 100%. And every segment that we cut out of the circle represented a percentage of 100%, a proportion of the 100%. So if you're greedy, your pie chart is going to be the entire pie. Half of that would show 50%, a quarter of that would show 25%. So here is an example of a pie graph, percentages of household waste in a certain Johannesburg suburb. How do we draw that, and what are the important points that we should remember when we're putting a pie graph together? Remember, it is a diagram, it must have a heading, and that heading must reflect the variables, the percentage of the waste, and we're looking at different households or suburbs. We're going to make sure that that circle represents 100%. The size of each sector represents the proportion of each of the measured aspects. It must have a key, or you must be able to neatly label the sectors. So you'd be able to label on here organic, biodegradable, waste, but that's a lot of writing to put into a small amount of space. And so on a pie graph, particularly if the sectors become very small and we can't write long labels, we use a key. And therefore it's important that you do take into an exam some different colors that you'd be able to shade this information in. How do you calculate what size the sector should be? Let's have a look at the formula, and don't worry, it's one of the things that you would do in maths literacy, should I say. It's not a difficult maths formula, it's very simple, but maybe you want to take it down on a piece of paper so that you remember how to do it. You have to calculate the percentage of the variable, and what you do is you take the variable, divide it by the total, and you're going to get the percent. You now have to convert that percentage into degrees, because remember, the circle itself is 360 degrees. So here's an example. If I find out that a certain suburb has 30% of their waste being organic, I have to go 30 divided by 100 multiplied by 360, and that is going to give me 108. And 108 is the number of degrees that is 30% of the total. And then what you have to do is you use a protractor. You're going to divide the circle up into sectors, and you're going to measure out 108 degrees. So this is important for you to remember. If you go into an exam or a test where you know that there's going to be dealing with data and you know there's going to be data response questions, you need to take obviously your pencil and pen, eraser and ruler, but you also need to take a compass to draw the circle, and you need to take a protractor in order to measure the various different degrees. Here is an example of another kind of graph. It is called a histogram. And you might say, but hold on, that's just a bar graph. But it isn't a bar graph. Can you spot why this isn't a bar graph? All right, you should be jumping up and down saying there's no space between the bars. The bars are jam-packed together, and the values or the variable on the x-axis, or the independent variable, is numerical and therefore continuous. So what's going on here? Well, this is called a histogram. And what happens with a histogram is we take the variable that is continuous, but we divide it into ranges. We say the information from 20 to 30%, the information from 30 to 40%. And so we've got the information here where it's not every single learner that we're plotting on an individual bar graph. We're taking groups of learners. We're saying all the learners that got between 20 and 30%, well, there were probably about 2 of those learners. How many learners got between 30 and 40%? Well, there were about 5 of those learners. And we put the continuous data into groups, or the word that we use is we put them into ranges. And in this way, you can see very clearly that the graph bars must touch each other because they show continuation. 30% leads on to 40%, which is linked to 50%, and so on all the way up the axis. Here's another example. Number of HIV positive babies born per 1,000 births to women of different ages. And what we've done is we've put the ages into different categories. We've said 10 to 15-year-old mothers, 16 to 20-year-old mothers, and so on. You should be able to recognize all this information very quickly. Dependent variable on the y-axis, independent on the x, labeled axes, heading, and because the independent variable is continuous but grouped into ranges, the bars must touch each other. And in the histogram, the variable is shown in ranges. I told you when we started looking at graphs that graphs were really useful because they could show a pattern or a trend, and that's very important when you have to interpret graphs, that you can see what kind of a relationship exists between x and y. Is it a direct relationship with both x and y increasing? Is it an indirect relationship with x increasing but y decreasing? Or is it a constant relationship? You need to be able to look at a graph that has been drawn and work out what the trend is. I hope that you've got some valuable information today on how to deal with data in the life sciences. Goodbye, till next time.